When we talk about Starship Flight 5, we're talking about that smooth liftoff, the spectacular booster catch, and the roar of engines shaking the sky, trailing brilliant orange flames. Absolutely breathtaking. So, no wonder people love it. But for that very reason, space fans often overlook one critical thing: the launch pad. On the other hand, for the engineers behind Starship Stage 0, the launch infrastructure is never an afterthought. SpaceX is now forging ahead with the construction of a revolutionary launch pad, engineered to be stronger, more resilient, and designed to withstand and minimize damage after every launch. Let's find out everything in today's episode. Without a launch pad, no rocket can ever take flight. If the pad isn't solid and well-designed, the rocket simply will be destroyed. And perhaps no company understands this better than Elon Musk's SpaceX, especially as they face a monumental challenge: building a launch pad for Starship, the tallest, most powerful rocket in human history. In 2019, on the coastal plains of Boca Chica, Texas, SpaceX engineers had to tackle an incredibly complex problem. How do you construct a launch pad that can withstand the enormous weight and power of the largest rocket ever built on soil that's too soft, with groundwater levels so high you can't dig more than a few feet down? They brought in 300,000 cubic yards of specially reinforced soil, carefully compacting each layer to create a solid foundation capable of supporting the entire launch system. On top of this reinforced base, SpaceX built the Orbital Launch Mount, OLM, from reinforced concrete, a massive circular structure designed to hold the entire rocket, with space underneath for Starship's 33 Raptor engines to unleash their thrust during ignition and liftoff. While the current launch pad at Starbase has proven impressively capable in recent tests, there's always room for improvement. In a recent conversation with Tim Dodd, Musk revealed his ambitious plan for a complete redesign of the OLM. The first signs of this new design began appearing about 2 months ago at Starbase's construction site for the second launch tower. On Platform X, Musk shared, "The new launch pad is designed to withstand a thrust of 10,000 tons, nearly triple the power of the Saturn V rocket that sent humans to the moon. This 10,000-ton thrust is the anticipated power of Starship V-3, the most powerful version in SpaceX's development roadmap till this time." This detail subtly confirms something significant. Even though the current pad is impressive, it's still not enough to meet SpaceX's ultimate goals. Now, let's look at what's projected for the new OLM structure. Instead of retaining the traditional round design like Pad A, the new launch pad is built with a square structure. At its center remains an opening to channel the exhaust flow from Starship's Raptor engines, similar to Pad A's OLM design. This structure will be surrounded by thick metal plates to ensure the system's integrity, capable of withstanding not only immense mechanical pressure, but also the extreme heat generated by 33 Raptor engines firing simultaneously. Inside this square structure lies a complex network of interwoven steel beams. This beam system is arranged to follow the principles of load distribution, creating a solid, three-dimensional framework capable of evenly dispersing the weight of the rocket. The most significant difference in the new OLM design lies in its base system. Unlike Pad A's traditional 6 fixed legs, the new structure stands on 4 specialized support legs. According to analyses from the spacewatching community and industry experts, these support legs are likely designed to be mobile, a groundbreaking innovation in rocket launch pad design. This design closely resembles the static fire stand at McGregor, Texas, though at a much larger scale, and featuring dedicated clamps to securely hold the rocket during launch. If this hypothesis holds true, SpaceX is executing an incredibly smart strategy, building multiple interchangeable launch pads. After each launch, the used pad could be moved to a maintenance area, while a freshly prepared pad is brought to the launch site. This method could drastically cut down turnaround time between launches, one of SpaceX's most critical objectives to date. But the differences in the new OLM won't stop there. Many related systems are set for significant upgrades. I'm talking about a new flame trench. Do you remember the condition of OLM Pad A after the IFT-1 launch? Back then, the OLM lacked a proper flame trench. This absence led to severe consequences. The incredible force from 33 Raptor engines blasted away tons of concrete, creating a storm of debris and dust that spread for hundreds of meters, even carving a deep crater beneath the OLM. Learning from this incident, SpaceX's engineering team developed a new solution: a multi-layer steel plate system cooled by water, installed at the base of the OLM. This setup is a complex, perforated structure, strategically designed with multiple openings. During launch, an enormous volume of water is pumped through this system, forming a water wall capable of absorbing heat, sound, shockwaves, and the immense force of liftoff. Picture it like a giant showerhead mounted upside down. The system sprays powerful streams of water outward at a 30 to 40 degree angle from the center, redirecting hot gases and flames away from the launch pad area. While it acts as a basic flame diverter and has proven effective, it's still not the ultimate solution. Tests at the McGregor facility have demonstrated the exceptional effectiveness of a complete flame trench system. Recognizing this, SpaceX has decided to integrate a similar but significantly enhanced system into the design of Tower 2. Based on structures observed at the Sanchez site, it appears that SpaceX is developing a dual flame deflector system, a complex yet more efficient design than the one used at McGregor. Take a look at this concept image, a V-shaped flame diverter. This design creates a flame trench with two exit paths, effectively channeling hot gases and intense pressure in two separate directions. When the rocket launches, hot gases and flames from the engines will be guided along these two branches, safely dispersing them at a distance from the pad and rocket. If you want to know what it might actually look like, take a look at this image. It's quite similar. This dual design offers several major advantages over the traditional single trench system. It disperses pressure more effectively, enhances cooling capability, minimizes concentrated heat buildup, and reduces surface erosion. Well, the large flame trenches used at launch complexes 39A and 39B at Kennedy Space Center in Florida during the Space Shuttle era are perhaps some of the best and most visible examples of how effective this design can be in managing extreme forces and heat. So, not only do I look up to the skies, but I can also see the future just by looking down at the starbase ground. And yes, I have one more prediction, saved for last because it's not fully certain yet, a potential redesign of the Booster Quick Disconnect BQD system. Currently, on Pad A's setup, the BQD is fixed directly to the OLM. When Starship's 33 Raptor engines ignite simultaneously, they unleash blistering temperatures, reaching thousands of degrees Celsius. To handle these brutal conditions, SpaceX has outfitted the BQD with a special armored shell, much like a tank, to ensure it can withstand the intense exhaust gases over multiple launches without needing major maintenance. However, SpaceX's new direction toward a mobile launch platform may reveal limitations with a fixed BQD design. From a cost perspective, each mobile OLM would require its own specially protected BQD, which could significantly raise production and maintenance expenses. Operationally, connecting the BQD to the booster would also become more complex if the OLMs were mobile rather than fixed. A potential solution from my analysis is that SpaceX might develop a BQD system integrated directly into the launch tower, similar to the quick disconnect setup currently used for the Starship itself. This way, the BQD could retract after each launch, avoiding direct exposure to the hot exhaust flow. Plus, having a single BQD system that serves multiple OLMs would greatly reduce overall costs. This approach would make for a simpler, much more elegant design. Do you think this idea is feasible? Currently, SpaceX has completed the installation of all its modules, giving the impression that Launch Tower 2 is almost ready to go. And while that's not entirely wrong, it's also not quite the case. The real reason the launch tower isn't operational yet is due to the OLM, chopstick crane system, and the quick disconnect. Completing these components takes significantly more time and effort than simply setting up all its modules. Personally, I speculate that once Launch Tower 2 is up and running, SpaceX might go back to Pad A, revamping it with the new design to optimize the entire launch process. The tricky part is that it's tough to predict when Launch Tower 2 will be operational. Building an OLM is far more complex than it seems, not to mention it will need rigorous testing to prove its reliability. However, with SpaceX's solid experience building the OLM for Pad A and their unmatched expertise in assembling structural modules, they're certainly up to the challenge. So what do you think? How much longer until Pad B's OLM is fully operational? Comment below. That's it for today. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more in-depth looks at the latest advancements in space technology. Thanks for watching, and I'll see you next time.